Welcome to the Cocotb, Python-based RTL verification. Through this course, you will gain a deep understanding of how to leverage Python and Cocotb for effective and efficient RTL verification. Whether you are a working professional or student, this course is designed to provide you with the skills and knowledge necessary to excel in your career in the RTL verification or design. In this course, you will get hands-on learning, engage with interactive tutorials, practice, exercises, and projects. Ready to download and use Ubuntu Virtual Machine with pre-configured environment for assignments, labs and projects. Expert guidance, live Q&A sessions with instructor. Access to a wealth of course materials, scripts and additional readings. Let's walk through the course syllabus and schedule. In week 0, we'll cover the prerequisites and setup required for this course. Module 1. Getting started with Cocotb. We'll start by introducing you to Cocotb, including its installation and basic usage. Module 2. Python Basics. This module will cover the fundamental concepts of Python programming, ensuring you have a solid foundation. Module 3. Python Advanced Topics. We'll dive deeper into advanced Python topics that are crucial for effective verification scripting. Module 4. Python Object-Oriented Programming. Here, you'll learn about object-oriented programming in Python, a key skill for organizing your test benches. Module 5. Python PyTest. We'll explore PyTest, a powerful testing framework in Python, which will be useful for writing and running tests. Module 6. Git and GitHub Classroom. This module will cover version control using Git and collaboration through GitHub Classroom. Module 7. System Verilog Refresher. Lastly, we'll have a refresher on System Verilog, the hardware description language we'll be verifying. In week 1, we'll focus on the fundamentals of RTL verification and various methodologies. Module 1. Importance of RTL verification. Learn why RTL verification is critical in the chip design process. You'll also read Trouble Ahead for IC Verification to understand the challenges. Module 2. Verification Methodologies. This module covers different verification methodologies, helping you choose the best approach for your projects. Module 3. Introduction to Python-based verification with Cocotb. Get introduced to Python-based verification using Cocotb, setting the stage for practical test bench creation. Live interaction with instructor. Participate in a live session to discuss these topics and clarify any doubts. In week 2 delves into the Cocotb framework. Module 1. Overview of Cocotb framework. Understand the overall structure and components of the Cocotb framework. Module 2. Components of Cocotb. Learn about the different components that make up Cocotb and their roles. Module 3. Interaction with RTL simulators. Discover how Cocotb interacts with various RTL simulators to perform verification tasks. Module 4. Test bench structure and execution. Study the structure of Cocotb test benches and how to execute them effectively. Live interaction with instructor. Join a live session to go over these modules and address any questions. In week 3, we'll continue exploring the Cocotb framework. Module 5. Signal management and manipulation. Learn how to manage and manipulate signals within Cocotb. Module 6. Coroutines and trigger system. Understand the use of coroutines and the trigger system in Cocotb for efficient test bench operation. Module 7. Logging and debugging in Cocotb. Discover techniques for logging and debugging within Cocotb to ensure your test benches run smoothly. Live interaction with instructor. Participate in a live session to discuss these advanced topics. In week 4 focuses on writing simple Cocotb test benches. Module 1. Basic test bench structures. Study the basic structures of test benches and how to construct them in Cocotb. Module 2. Test benches for combinational designs. Learn to write test benches for verifying combinational logic designs. Module 3. Test benches for sequential designs. Explore the creation of test benches for sequential logic designs. Live interaction with instructor. Join a live session to get hands-on guidance. Lab demo. Participate in a lab demo to see practical examples of test benches in action. In week 5, we'll verify basic modules. Module 1. ALU verification. Verify an arithmetic logic unit, ALU, using Cocotb test benches. Module 2. Test benches for FSM-based designs. Learn to write test benches for finite state machine, FSM-based designs. Live interaction with instructor. Engage in a live session to discuss these verification tasks. Lab demo. Participate in a lab demo to see these verification techniques in practice. Week 6 covers advanced test bench structures. Module 1. Class-based test benches. Study class-based test benches for more structured and reusable code. Module 2. Bus functional models, BFMs. Learn about bus functional models and how to implement them in Cocotb. Live interaction with instructor. Join a live session to delve into these advanced structures. Lab demo. Participate in a lab demo to see these advanced techniques in action. In week 7, we'll verify interfaces and protocols. Module 1. AMBA-AXI protocols verification. Verify AMBA-AXI protocols using Cocotb. Module 2. Serial Peripheral Interface, SPI, protocol verification. Learn to verify SPI protocols with Cocotb test benches. Module 3. Inter-integrated circuit, I2C, bus protocol verification. Study the verification of I2C bus protocols. Live interaction with instructor. Participate in a live session to discuss protocol verification. Lab demo. Join a lab demo to see protocol verification in practice. In week 8, we'll cover verification planning and strategies. Live interaction with instructor. Engage in a live session to discuss comprehensive verification planning and strategies for your projects. Finally, we'll work on a capstone project. Capstone project introduction. Begin your capstone project, applying all the knowledge and skills you've gained throughout the course. Live interaction with instructor. Participate in live sessions to receive guidance and feedback on your project. Note for learners, all the course content will be available relative to your enrollment date. However, live sessions are scheduled according to calendar dates. Students can join any available live meeting in the respective week. These live sessions are scheduled separately between July 8, 2024, and December 31, 2024. The respective live sessions will be recorded and made available under the corresponding weeks. We encourage you to actively participate in the live sessions and make the most of the recorded content. This course is designed to provide you with the skills and knowledge needed to excel in RTL verification using Cocotb. We look forward to seeing your progress and achievements. Happy learning!